Hi, everyone. I'll start with a question, an unplanned one. I'm data-driven. So with a raise of hands, how many people have data scientists in their companies? Okay. How many people have ML engineers, like someone with that title? Okay. And MLOps people? Okay, less, but still some. Awesome. So let's talk about solving MLOps from first principles. So today, 80% of machine learning teams have models in production. At the same time, they have over 300 ML tools to evaluate and choose from. All of these tools have vague marketing messages, unclear interfaces, and so, as you might imagine, this can cause a lot of confusion and grief. What we're going to do in this talk is present sort of a 5-step framework that will help you solve your MLOps problems from first principles. So my goal with this talk is to hit somewhere between, if you know nothing about machine learning, you're still going to get a set of effective tools and ideas that you can apply to your own decisions. But also, if you are familiar with MLOps, this is not going to be, hopefully, not going to be a repetition of things you already know. And I think that that's the holy grail for talks like these. So, a few words about me. My name is Dean. Thanks for joining this talk. My background is a combination of physics, computer science, and machine learning. And what you need to know about me for the purpose of this talk is I am very excited about building tools for machine learning teamwork. I am also a strong believer in open source, and specifically the role that open source has to play in the world of machine learning and machine learning tools. I am the founder of DAGS Hub, which is building the GitHub for machine learning. So we are combining really awesome and popular open source tools and building a layer on top of them that makes it easy to work with, build a cohesive workflow, and work as a team. And I'm also the host of the MLOps podcast, where I talk to industry experts about getting machine learning models into production. And so that sort of answers the question of why you should be listening to me. And you can also follow me on social media. That would be awesome if you like more content like this. And so first principles thinking, let's define what that is. So it is a mode of thinking or a mental model where you break a problem that you might be facing down to the most fundamental truths that you know. So the things that you know with most certainty are true about the thing that you're looking at, and then try to reason about the solution from there. So it is not a top-down or analogous way of thinking, but a bottom-up approach. And of course, Elon Musk has made this approach famous with sort of Tesla and SpaceX, but it goes back to Aristotle. And so one of the feedbacks that I got when I was practicing this talk is that it's going to apply to any sort of tool choice process that you might go through, but I'm going to use examples from the world of MLOps and from our own experience. And so you might also sort of ask, why do you need a framework? Like, you've evaluated tools, you've already chosen tools to use with, and you're going to do that many more times in the future. But what we've experienced from our own sort of processes is that many times this process takes longer, is more painful, and then ends up costing more money or working less efficiently than you'd hope for. And by building a framework that is sort of consistent and coherent, we can save a lot of that pain and grief. So you might be familiar with this statistic of 87% of machine learning models never make it to production. And if you're not, don't worry, it is probably wrong. There are too many ill-defined parameters for this to actually make sense. But what I want to the point I want to drive with this slide is that a year or so ago, the overwhelming vibe of the sort of ML field was everyone was running around with their models running in some sandbox or Jupyter notebook, trying to figure out how to get them to production, to become a part of their product. But as I said in the beginning, this is no longer the case. And over 80% of ML teams have models in production, with almost 25% having over 10 models in production. So this is no longer the domain of the Googles and Amazons of the world, where everyone else is looking at them saying, I want what they have. Small startups, traditional organizations are at that point. And they are sort of facing the next challenge, which is scaling from 1 to 10, 10 to 100, or in general, 1 to many. And so for that purpose, they are looking for workflows that can tie everything together and a stack that they can use to actually get them past that point. But then they go and look outside, and we like to call this, or I like to call this MLOps fatigue. They find a ton of tools. Everyone promises that they're the best thing since sliced bread. And it's really hard to understand how to go about making these decisions. And so usually people end up in one of two paths. The first is they go end to end. So they go with a tool that promises it will do everything that they wanted, give them a foot massage while their model is training. But then those tools have a tendency to break on the edge cases, to not be really customized for their needs. Or they go the other path and go with best of breed. So they pick and choose the tools that best solve their problems. But then they have that extra step of integrating them themselves and holding the project context, usually within someone's head or in some Google sheet hidden somewhere in the dark. And so this usually leads to a process which is kind of like the 4 stages of grief. And let me know if this resonates. So the first step is you do everything manually. And in the beginning, that is completely okay. But at some point, you're going to start losing time or work or sleep, worst of all, on things that could be easily solved if you had tools that were just a bit better. And so then you get into the next step where you look outside, you realize that there are so many tools and you need to make a decision. And then usually you get into analysis paralysis. You look at all the tools, they promise everything, and you need to evaluate them properly, understand the cost benefits and everything. And at some point you realize that the time you spent evaluating these tools was longer than the time it could have taken you to just implement them. So you're sort of a bit winded, and you decide that the next step is going all or nothing. You need a tool that will solve everything, and you start to simplify your life by ruling out everything that does not solve every problem that you already have and you might have in the future. But at some point, going that route, you will discover that doing everything means usually being mediocre at everything, and you deserve the best tools, right? So being frustrated, you decide that you're going to build everything in-house. You know what you need best, so why not just roll up your sleeves and do it? But of course, you didn't build your own GitHub. You don't have your own cloud service. So why does it make sense in this case? I would argue that this is probably the most resource-intensive approach, and also because this is not your core business in most cases, the result you're going to end up with is going to be worse than the alternative. So if you're Google or Facebook and you have virtually infinite resources, it might be the right solution for you. But as we'll see in a moment, the first assumption that I'm going to make about the problem is that you are not Google or Facebook. This point is named after a really good blog post. Google this. I really recommend it. So if you're going to build everything yourselves, you're going to need a team of 70 DevOps professionals for one data scientist that is running linear regression. That is probably not what you want. And so that's sort of one aspect of it. The other is that a sort of MLOps is a rapidly changing field, so that many of the tools that you use today are going to look tools and workflows are going to look very differently in the next sort of few months or years. And so if you take one thing away from the assumptions about the problem, it should be that it is all a matter of trade-offs. So you want to balance 3 things, basically. You want to be production ready, you want to save time and money, and you want to be future-proof. And everyone is going to prioritize differently between these 3 points. But it's important to put your mind to all 3 criteria so that you're not surprised later on when it doesn't, when the solution you choose is not sort of appropriate for your needs. So now that we talked about the assumptions that we're making about the problem, let's talk about the assumptions we're making about the solutions that we're going to choose. So the first thing is being problem versus feature focused. And what I mean by being feature focused is you describe your needs from the perspective of existing solutions. And that might limit you in 2 main ways. The first is, it is possible that all the existing solutions are not good for your specific problem. And in that case, maybe it does make sense to build something from scratch. But if you start describing things from the perspective of solutions, you're going to be sort of mentally locked into these things. And the second thing is that in many cases, the sort of this approach will lead you to be drawn after the latest buzzwords that everyone is talking about, instead of actually going after the problems that you have and solving those. So what I would recommend is to be problem-focused. The second is you sort of want to, you need to realize that there's a huge difference between what happens until you get to production and after you're in production. And so this is also a recommendation on how to approach building a new project, which is you want to create a pipeline that, even if it's very simple, goes through productionization very early, so that you can find the real points of friction that you have and then fix them. The ML twist. So a lot of the tools that exist for machine learning teams have have taken inspiration from developer tools. And that makes sense because there has been a lot of blood, sweat, and tears gone into building these tools over a long period of time. But at the same time, the sort of fields are fundamentally different. One is, in one sense, it's the data that needs special treatment. And the way I explained this to a few people today, the way you want to start thinking about this is that data is part of the source code for a data scientist or machine learning engineer. And that means that the systems that we're building need to pay attention to that. But you can also think about CI/CD specifically. So imagine every push to master is going to create a pipeline that needs 8 GPUs and is going to run for 48 hours. And how do you create a system that can actually support that at an organizational scale? Last but not least, building on open source software is always an awesome idea. But in cases where the field is fuzzy, like the cases for machine learning, this is extra important. So if you are working on a system, and if you're working with an Oracle SQL system, you can assume that in the next few months or next few years, everything is going to be plus minus the same thing with the same requirements. But with machine learning, having that escape hatch of diving a layer deeper, building an extra integration or modifying something for your needs might become very critical down the line. So now that we got sort of the assumptions out of the way, what we're going to do is we're going to take the example of data versioning, and we're going to build a framework along with this thing. So first things first, you might say, I want to version my data, right? That's what we're talking about. But I'm going to claim that this is actually bad form. And what you want to say is my data is regularly changing, and I want to revert back to an older version for disaster recovery. In other words, the first step of our process is defining the problem, right? And this might sound trivial. I'm going to repeat that sentence a few times, but the idea here is that by deciding the goal that you're trying to achieve, you're going to be better at choosing the tools that will help you achieve it. And so writing this down or putting this in words in a very explicit way is super important and will help you avoid analysis paralysis. And so basically the first version on top is the thing that is sort of being more feature focused and will lead you down the wrong path. So just to drive my point home, here are 3 examples for problems you might have, which can all be solved by data versioning, but will lead to arguably completely different tool selections and different priorities. So you can say, I want to revert in case of a bug. You can say, I want to know where my data is used within the organization. Or you can say, I'm editing my data and I want to make sure that I'm not going to break the applications or systems of downstream consumers. And so it's very important to know what is the problem that you're going to solve. 2 pitfalls that we've seen happen over and over in this. One is an ad hoc definition. So what I mean by this is the first step is not an excuse to do post hoc rationalization. So you choose the feature that you want or the tool that you want, and then explain that you actually have a problem that that tool is going to solve. So if you catch yourself doing this, this might be sort of a light bulb should light above your head, and you should realize that you want to take a step back and make sure that this is a real problem. The second is going with all of the above. So you hear about a ton of different problems, and you say, we need to solve all of them. And that's usually a sign of one of two things. Either you have gone down the feature path, or the first problem that comes to mind is the actual problem that you're trying to solve. Okay, so now we know what our problem is. And so we're going to say we need to get a flexible tool that supports data versioning so that we can revert in case of an emergency. But this is also bad form. And so what I would sort of recommend we say is we need a tool for tabular data that supports add-only changes and works with MySQL databases. And so the second step is outlining the problem parameters. And what this means in practice is basically asking yourselves a bunch of questions. Some of these questions are going to be problem specific. So in the case of data versioning, you're going to ask, is my data images and I'm working on computer vision? Maybe it's tabular. Is it sort of changing over time? Is it add only? Or could it be changed retroactively under my feet and I have to handle that? Another set of questions are going to be around organizational constraints. So what are the systems that are already in use in my company and this tool needs to support? Can we change the schema of our database in order to support a tool that we're going to evaluate? Things like that. And the last type is philosophical questions about yourself. Who am I? No, what I actually mean is sort of, are you a shell scripting wizard or a sysadmin with little ML experience? And this might not refer to you specifically. It might be the profile of the average person in your organization or the company culture itself. And this is going to introduce a lot of counterintuitive considerations into the work that you're doing. So again, a few points to note. Organizational constraints are arguably the most important. They usually provide the most exhaustive list of considerations to take. And so if you only ask one set of questions, do this one. And then another effective way to do this is defining a user story. This is usually going to be an internal user story or a workflow that goes through the process of it using this tool or sort of having this problem. And just to give an example, you could say, I want to version the database directly, or in some cases, you want to version the queries that the data scientists run in order to train their models. And each one, again, is going to lead to a different set of priorities and tools that you look at. And so now we did all the hard work of defining our problem and outlining our parameters. And so the next step is going to roll up your sleeves, open an empty code editor, Vim, Emacs, whatever you like, and just build your tool from scratch. You can hack away, you got this. And I'm of course joking. We're engineers, and we like building awesome things, and it's even better to build awesome things that other people are using. But in many cases, this is not the correct decision. And so the actual next step is to Google the problem. And this might sound trivial, but you would be surprised how many people spend 5 minutes researching existing tools before settling down on spending many months developing an internal solution. And so I'm going to provide a few tips and pointers on how to make this process more robust and effective. And the first one, of course, is to budget an adequate amount of time. And what I mean by this is probably 2 to 3 hours, if not more, to research the existing solutions. And this is part of where the dividends from the earlier steps of the process come in. So if you spent the time needed to define the problem and the parameters, you now have a set of keywords and terms that you can use to search for. And so you don't only want to search for tools, but even more importantly, search for the things that you defined in step 1 and 2. The second thing is to build an info page. You want to have that discussion, or at least you're going to want it in 2 months when someone starts questioning whether or not you checked a certain tool. It will let other people add ideas for tools, add priorities that maybe you forgot to add, or add keywords that you might want to search for. And probably the first thing that you're going to learn in step 3 is that you were searching for the wrong words. And that is okay. And in order to solve that, what you're going to do is you're going to read blogs and ask friends, colleagues, and random people on Reddit about your problem. And the idea here is not to learn about new tools, but to learn about new terms that you can search. And I think that this is sort of a counterintuitive fine point that you should notice, especially when you're asking people. A lot of times the talk just revolves around the tools that we might or might not use. But that's going to miss the point and again lead you to analysis paralysis and the feature path. So to give a few examples, this is how your Google search might evolve over time. And I'm not saying that the term on the top is bad. It is probably better as a title for a Reddit post. And the second thing is when you're in Reddit, so I actually grabbed a few examples. So these are real people that posted on Reddit in sort of threads that relate to data versioning, is you want to describe the problem, just define the problem parameters as we did before, and then ask people how they solved it and look for a list of terms that you're going to use. Now, many times, there are two counterintuitive points here. Many times, people will just respond with, oh, just use tool X. It's great. I'm using it all the time. And so your goal here is to get as many responses as possible. So if someone responds that way, that's awesome, but just ask for clarification. Do that follow-up question and don't treat it as just like a vote. And the second thing is, at least in the world of sort of machine learning and MLOps, Stack Overflow, which as developers is a great place to go to, is less successful than, for example, Reddit. So I would note that as well. Okay, so we defined our problem, we outlined the parameters, we Googled the different things that we learned, and now we are sort of, we have a short list of tools. And so what we're going to do next is 700 Hello World tutorials. This is the fun part, right? You try everything out and make a decision on what makes sense. And I, of course, as you might have anticipated by now, don't recommend that. And I think that there's an extensive evaluation process that you can go with that will help you prioritize and sort of minimize the amount of Hello Worlds that you're doing. And so the first thing is pre-technical evaluation. So you want to look at the different parameters of the projects that you're evaluating without even installing them or playing around, just to see that it makes sense for you to take the next step. After that, you want to see that the operating principles are presented and actually make sense. Then you're going to go ahead and do the Hello World tutorial. And what I think is the main dividend of this process so far is that instead of doing 700 of these, or 5 or 10, you're going to do 1 or 2. Because you did a lot of work in preparation to make this process already more prioritized and be closer to the target that you're actually aiming for. And then finally, you want to kick the tires mechanically, and I'll explain what that means in a moment, but the idea is basically if you have a specific dimension where you know you're going to hit scale early on, you should test that as soon as you can. So pre-technical evaluation, or sorry, this is the evaluate stage. And let's talk about pre-technical evaluation. So usually we go with GitHub stars, right? Like everyone knows that if your tool has a ton of GitHub stars, it is awesome. And I'm not trying to take away from that, but I think that GitHub stars are many times less indicative than other things, like how many open and closed issues there are, how many contributors there are, when was the last commit. When you look at issues, are there many unanswered issues? Is there an issue that was open 4 months ago and no one responded to? And so when you're looking at the sort of face value comparison between these tools, the stars might paint one picture, but the other metrics might paint another. And that is many times counterintuitive, so I recommend looking at this in the pre-technical evaluation. The next thing is, let's take one tool for data versioning, which is called data version control. I'm familiar with that, and you look at the operating principles for DVC. The idea is it saves pointer files to your data within Git. It can push those data files afterwards as a hash table to any remote object storage that you use. And that's awesome, but maybe it's not for you. If your data is stored in a MySQL database, it might not be the right solution. And so being able to understand the operating principles will help you understand what the creators of the tool care about and what they emphasize, and whether or not that is the same things that you care about and emphasize in your search for a solution. When we get to the Get Started tutorial, again, I mentioned this already, but the idea is that you're going to do significantly less of those. But also, I think that one important point here is that people like to focus on how easy it is to do the Get Started. But I think that's less important than you might think. If it takes an hour to set up the tool as opposed to 2 lines of code, that's okay if the value after that hour is what you're looking for. So in the case that we looked at in the beginning, where your goal is to have a versioning solution that will help you revert in case of disaster, hopefully, even though some of the talks that we heard before might point otherwise, you have a disaster not every day. And so you want a tool that will enable you to get this benefit without adding a huge burden to your day-to-day work. So finally, kicking the tires. I'll give an example because I think it makes the most sense. So let's say I'm working on a computer vision project, and I know that my data is in the order of magnitude of 10,000 or tens of thousands of images. You might be tempted to say, well, we'll try to use this tool, maybe it's DVC, we'll try to use DVC with the sort of hello world, and if it works, then it's going to be okay. Maybe your data set isn't ready yet, so you want to wait for it to be ready. But what I'd recommend with respect to the stress test is you create a script that generates 20,000 images that are just noise and add them to DVC to make sure that it would actually support the scale that you're looking for. We're almost at the end, so step 5, right? We've evaluated our solutions, and now it's time to integrate the chosen one. And so the pitfall here is going all in, or drowning in success criteria. And to sort of live up to my meme, that's not what I recommend. And I think that there are 3 pointers that you should notice for this step. The first is start simple. Start with one project, one user, one unit of whatever it is this tool is going to support. You will learn a ton from this first round, and it will save you a lot of tears and time to do it gradually. This is the part where everyone says you should define clear success criteria so you can analyze the cost benefit of the tool and make sure that it makes sense for your company or team to integrate it. And I think that's a great idea in theory. In practice, we are living in the real world, and many times the situation is that you know it when you see it, but it's hard to define it in advance. And so in that case, a good recommendation is to time constrain the whole thing. So say we're going to use this for a quarter, and then get back, regroup, and make a decision on how to move forward. Last but not least, it is very, very easy to not review your work. And I obviously do not recommend that. It is very important. You also want to make sure that you take note of the bottlenecks or trade-offs that you introduced into the system with this new integration. And the best way to make sure that this happens is you schedule the review discussion when you start the integration and not after. So we defined a 5-step process. We defined a problem, we outlined the parameters, we Googled it, we evaluated solutions, and then we integrated them. And I think that this is going to help provide structure and sort of add pointers to each one of these steps. And I think that also many of you probably already have such a framework that is maybe less fleshed out. And I think that one benefit of having something which is not hand-wavy is that you can, again, put constraints on your work, put constraints on your process, and then save a lot of time, money, and tears. So to make it easy to remember, I turned it into an acronym, which is DOGUI. Is it a coincidence? I don't know. You tell me. So thank you, everyone, for listening to this talk. Please follow me on social media and feel free to reach out to me. I will be here for your questions.